This video, I'm going to prove another fact about mappings. Let x lambda g be defined to be gx. That is, whatever this is, multiply on the left by g. And we also defined another mapping, tau sub g. Tau sub g acting on x is xg. That is, whatever this is, multiply on the left by g. And this is for all x in the group G. Show that for any element of the group G, the mappings lambda g and tau sub g satisfy this identity. That is, they commute. If you like watching mathematical proofs, subscribe to my channel, as this is what we do on this channel. Okay, so I'll even show you a trick about writing a proof nicely. I will purposely not do this proof very elegantly, and I'll show how you can fix that. Okay, so let's take this left mapping, lambda g tau h, and let's see what it does to the element x. So you get x lambda g tau sub h. Well, lambda is left multiplying by g. So for x, I multiply on the left by g. And then this gets acted on by tau sub h. Well, tau sub h takes that and then multiplies on the right by h. Now, let's suppose you're kind of new at this and you don't really know how to continue to finally get that this is x composed with tau h lambda g. So possibly, so I just want to say one last thing. This would be gx times h. Now, what you can do is you can now take x and see what this mapping does to it. So first, we'll map x via tau sub h. And what tau does to this is it multiplies on the left by h. And then lambda sub g comes into play. It takes whatever that is, multiplies it on the left by g. So now, what you can do at this point is, you can say that this equals this, just associative law, which equals this, which equals this, which equals that. That is, just write this backwards, and I will do it right here. gxh is the same as gxh, that's this line, or that part, which is equal to xh tau lambda g, we got that one, which is this, which is x tau sub h, because h multiply, tau sub h multiply this on the right by h, that's just what I have, times lambda sub g. So that's this part. Using the associative law, we get this. So it's in one nice string. So let's get rid of what we don't really need. This is not that pretty looking. Let us put back everything. Sorry about that. Now that we have that this is equal to that, they're both mappings, or composition of mappings, are both acting on the element x and g, and they're getting the same result. This implies that the two mappings are the same. They do the same to any old x and g. So let us say I should have said at the very beginning, let x be in g. And we concluded that the mappings were the same, and we wrote it in one sequence of equal signs. This equals this, which equals that, which equals that, which happens to equal this, which equals this, which equals that, which ultimately equals this last result. That is, we verified via a string of equalities that this and this are the same. And both mappings did its thing on the same element x, and it got the same answers. That is, the mappings are the same. It commutes. If you like watching videos like this, seriously consider subscribing to my channel, or actually do subscribe to my channel. Thank you for watching to the very end. Please click the like button, leave a comment, tell your friends and family about my YouTube channels. Most definitely get back at all your enemies and have them watch my videos. See you guys in the next video. Watch and learn.